You know, when we think about AI getting smarter, we usually just picture bigger, more powerful computers. But what if there was a way to make it not just more accurate, but way, way more efficient at the same time? Well, today, we're diving into a really fascinating new method called DeepConf that does exactly that. It's all about thinking smarter, not harder.
It kind of sounds impossible, right? In the world of large language models, getting a better answer usually means you just have to throw more computer power at it, which, of course, costs more money. It's always been this trade-off between quality and cost, but this is the exact puzzle the researchers behind DeepConf wanted to solve.
So to really get why this solution is so clever, we first need to understand how the top AIs are already tackling tough problems. And the best method we have right now is something that, honestly, looks a lot like a huge, chaotic, and really noisy brainstorm.
This technique is called self-consistency, and here's how it works. Imagine you ask an AI a really hard math problem. Instead of just trying once, it tries hundreds of times, and each time it comes up with a totally different way of thinking about the problem. Then it just looks at all the final answers it got and picks whichever one showed up the most often. It's really just a brute force majority vote.
Okay, but here's the big flaw in that whole approach. This majority vote system treats every single attempt as equal. So a brilliant, elegant line of reasoning gets the exact same single vote as a path that was full of nonsense and mistakes right up until the very end. You can see how this is just incredibly wasteful.
And the cost of that waste? It's staggering. To get just a small bump in accuracy on a single math benchmark, this old method can burn through an extra 100 million tokens. And a token is basically a piece of a word. It's the raw currency that AI models run on. So we are talking about a huge amount of extra work for a pretty small improvement.
This is where the big breakthrough happens. The researchers asked a really simple but powerful question. What if we could kind of listen in on the AI's thought process? What if we could tell how confident it is about every single little step it takes?
Now this is what's so cool. The old way of doing things only gave us what's called global confidence, a single blurry score for the entire answer, and you only got it after the whole thing was done. This could easily hide a critical mistake somewhere in the middle. DeepConf, on the other hand, introduces local confidence. This is like a high-definition, real-time score for every tiny step, letting us see the exact moment the AI starts to get unsure of itself.
And this quote from the research paper just nails the problem perfectly. Averaging the confidence over a long answer is like averaging the health of an entire hospital. It might look good overall, but it totally hides the fact that one patient in one room is having a complete breakdown, and that could jeopardize everything.
So, how does this all come together into an actual solution? Well, this is the DeepConf method. It takes this new local confidence idea and uses it in two really clever ways to make those AI brainstorms a whole lot smarter.
First, you've got the offline mode. This one's pretty simple. We let the AI generate all its hundreds of different answers just like before. But, and this is the key, instead of a simple one vote per answer system, we give more weight to the answers that came from a path where the AI was consistently confident. Basically, the most certain thinkers in the room get the loudest voices.
But the real game changer is the online node. This thing works in real time. As the AI is thinking step by step, DeepConf is watching its confidence level. The moment that confidence dips below a certain point, the instant the AI starts to waver, DeepConf just tells it to stop. Cut your losses. Don't waste any more time or energy on a path that's probably going nowhere.
So, does it work? Oh yeah. The results are not just good, they're frankly transformative. This is where we see the massive payoff for thinking smarter, not just harder.
Just look at this. On a super challenging math competition benchmark, the old method, self-consistency, was already amazing, maxing out at 97% accuracy, but DeepConf pushes that all the way to 99.9%. It basically makes the model's reasoning on this task nearly perfect. But here's the real kicker. It gets that near-perfect accuracy while using dramatically less computer power. The old way burned through over 320 million tokens. The most efficient version of DeepConf got an even better score using just 49 million. I mean, come on. Better results for a fraction of the cost. It's incredible. This number right here just drives the whole point home. Compared to the standard ways of doing things, DeepConf can slash the number of tokens generated, that raw computational work we talked about, by almost 85%. That is a gigantic leap in efficiency.
Okay, so these are great numbers for the researchers, but what does this actually mean for the rest of us? Why should we be excited about this?
Well, this efficiency translates directly into huge real-world benefits. It means the AI tools we all use can become faster and more responsive. It means these super powerful models become cheaper, making them accessible to everybody, not just giant tech companies. And we get more reliable AI for really critical fields like science and medicine. Ultimately, it just means we can start using AI to solve problems that were simply too expensive to even try to solve before.
And that really leaves us with a big, exciting question. When you make our most advanced AI, thinking almost 85% more efficient, what new frontiers suddenly open up? What problems that seemed impossible just last year might now actually be solvable? That's the future that a breakthrough like this points us toward.